Welcome to IT.Solution, your total network, system, firewall, and security partner.
Welcome back, everyone. I am super excited to have you here for today's explainer, where we're diving into SRWE Module 4 Inter-VLAN routing. If you're gearing up for your CCNA or just looking to level up your enterprise networking game, you are exactly in the right spot. We're going to look under the hood at how networks actually communicate, so let's jump right in. So think about this for a second. How exactly do you get completely isolated VLANs to talk to each other? You can think of a VLAN, a virtual local area network, kind of like a secluded island. The folks on that island, they can chat with each other all day long, no problem. A layer 2 switch handles that local traffic perfectly. But if they want to send a message to a completely different island, they need a bridge. And in our world of networking, that bridge is layer 3 routing. To get us there, here's our roadmap for this explainer. First, we'll look at the inter-VLAN problem. Then take a quick trip to the past with legacy routing. After that, we'll hit the present with router on a stick, look at the future with layer 3 switches, and finally wrap up by troubleshooting some common issues.
All right, section 1, the inter-VLAN problem, bridging the gap. Let's look at exactly why layer 2 switches just can't pull this off on their own.
Simply put, inter-VLAN routing is the process of forwarding network traffic from one VLAN to another using a router or a layer 3 switch. Think about it. VLANs are literally designed to segment networks, right? We use them to break up broadcast domains for better security, better performance, and just general organization. But sometimes that security actually works a little too well. Like, what if your sales department genuinely needs to pull data from a server sitting over in the IT department's VLAN? Well, without a layer 3 routing service stepping in as a default gateway, hosts in those different VLAN subnets are completely and utterly cut off from each other.
Moving on to section 2, legacy routing, the past. It's actually pretty fascinating to see how early network engineers tackled this physical roadblock when VLANs were first introduced. Back in the day, if you wanted VLAN 10 and VLAN 20 to talk, engineers had to use a physical router. And I mean, they literally plugged a separate physical cable from the switch into a dedicated physical router port for every single VLAN. So you'd have gigabit 0/0/0 for VLAN 10 and gigabit 0/0/1 for VLAN 20. And hey, it worked. But just picture trying to pull that off in a modern enterprise network with, say, 50 or 100 VLANs. There's just no way. This clunky legacy method ate up the router's physical ports instantly. It totally failed to scale because you just simply run out of physical ports.
So that brings us to section 3, router on a stick, the present. Once people realized those legacy limitations, a really clever workaround evolved, and it became the absolute gold standard for small to medium-sized networks. Take a look at how this setup builds on what we just talked about. Notice that single connection linking the switch to the router? That is one physical cable. But here's the magic. The switch port is configured as an 8021Q trunk. This is the classic router on a stick topology. By using a trunk link, we can actually divide that one physical router interface logically, allowing it to handle traffic for a bunch of different VLANs. The router just reads the 8021Q VLAN tags as they come in, routes the packet, tags it for the new VLAN, and then sends it right back down that exact same physical cable. Pretty slick, right? Now let's look at exactly how we configure this logical division in the terminal. When you look at the configuration, see how the sub-interface is created with interface G0/0/1.10? It is a huge best practice, and honestly, just common courtesy for whoever takes over your network to match the sub-interface number right to the VLAN ID. So here, it's for VLAN 10. Then, check out the very next line, encapsulation.1Q10. Guys, that is the absolutely crucial command. That tells the router, hey, expect and understand 802.1Q tags for VLAN 10 on this specific virtual interface. You slap an IP address on it, and boom, you've got yourself a default gateway for that VLAN. But as awesome as router on a stick is, we really have to weigh it against the reality of massive modern networks. The thing is, router on a stick maxes out efficiently at roughly 50 VLANs. Because think about it, you are still funneling all of that inter-VLAN traffic up and down one single physical cable. That creates a massive bottleneck. When you're dealing with the extreme scalability and bandwidth needs of a modern enterprise, this old reliable stick just isn't going to cut it. And that perfectly tees up section 4, layer 3 switches, the future. Large enterprises need routing at hardware-based switching speeds, which brings us to the modern era. This multi-layer setup brilliantly illustrates our modern solution. What we're dealing with here is a multi-layer or layer 3 switch.
Instead of sending traffic all the way out of the switch, up a cable to a router, and back down again, this multi-layer switch handles all the routing internally. It uses these things called switched virtual interfaces, or SVIs. As you can see, they act as the default gateways for the PCs on their respective VLANs. The routing is actually happening at hardware speed, right there on the silicon of the switch itself. It is incredibly fast and highly scalable. Setting this up is wonderfully straightforward too. Let's walk through the 4 exact configuration steps you need. First up, you just create the VLANs in the switch's global configuration. Second, you create those SVIs by typing interface VLAN followed by your VLAN number, and you go ahead and assign it an IP address. Third, you configure your physical access ports and assign them to their correct VLANs. And finally, step 4, and this is a big one, you must enable IP routing. Actually, let me pause right here and sound the alarm for a second. Consider me your mentor warning you on your very first day on the job. Step 4 is typing IP routing in global configuration mode. Do not forget this command. Seriously, by default, a layer 3 switch acts exactly like a standard layer 2 switch. You could configure all your SVIs perfectly, but if you forget to type IP routing, your switch will absolutely not route IPv4 traffic. You'll be sitting there pulling your hair out wondering why the network is down. So write that one down. Okay, so what if your brilliant new layer 3 switch needs to route traffic out to the internet through an external router? Well, you can't just use a standard switch port for that. You have to type the no switch port command on that specific physical interface. What that does is strip away its layer 2 switching capabilities and basically converts it into a routed port. It turns that single port into a true router interface, where you can assign an IP address and even configure a routing protocol, like OSPF. All right, let's wrap things up with Section 5, Troubleshooting Common Issues, the fix. We've designed it, we've configured it, now let's jump into the real world, where things inevitably break, and figure out how to fix them. Let's ground ourselves in this particular scenario. PC1 is trying to ping PC2, but it's failing. The support ticket just landed right on your desk. Now, when inter-VLAN routing is broken, the issue almost always boils down to a failure somewhere in the connectivity chain. You have to methodically verify the path. Start from the PC, go to the switch port, across the trunk, up to the router's subinterface, and then all the way back down again. To help you out, here is a rapid-fire mental checklist of the top configuration errors that every single CCNA candidate needs to have memorized. Number 1, missing VLANs. Did someone accidentally delete the VLAN on the switch, or is it maybe not allowed on the trunk? Number 2, misconfigured trunk links. Is that port actually trunking, or did someone hard-code it as an access port? Number 3, access port issues. Is the PC plugged into a port that's assigned to the wrong VLAN entirely? And lastly, router subinterface errors. Did you type in the wrong IP address, or map the subinterface to the wrong 802.1 Q tag? It's usually one of these culprits. Now, if you want to check those router subinterfaces quickly, I've got an absolute pro tip for you. If you just type show interfaces, you are going to get blasted with pages and pages of overwhelming output. Don't do that. Instead, use the pipe character to filter it. Type show interfaces, pipe, include gig, pipe 802.1Q. This instantly filters that massive wall of text to verify exactly what you actually need to know. Are my gigabit subinterfaces up, and are they configured with the correct 802.1Q VLAN tags? Trust me, this is a massive time saver, both for the exam and out in the field. And just like that, we've reached the end of our journey for today's explainer. We've successfully crossed the bridge from isolated islands to fully routed enterprise-grade networks. Before we sign off, I want to leave you with a quick thought. Which inter-VLAN routing method is running in your server room or even in your home lab right now? Are you relying on an aging router on a stick setup? Or have you fully embraced the sheer speed of Layer 3 switched virtual interfaces? Go check your configs, apply what we just covered, and I will see you in the next explainer.
Thank you for watching. See you in the next episode.